All right, on homework 3.8, you're supposed to be using L'Hopital's rule. The first three problems, you're doing it using the old limit techniques and by using L'Hopital's rule. So we'll do part A first for number one. Part A looks like a factor and cancel one because there's polynomials over polynomials. This is 2 times x minus 3 over x plus 3 times x minus 3. X minus 3 cancels, and then we can use direct substitution to get 2/6, which is 1/3. Now the question is, can we do this using L'Hopital's rule? And for L'Hopital's rule, we need to get 0 over 0. We should have checked this for part A also. We get 0 over 0, and so we can use L'Hopital's rule, and L'Hopital's rule says that it will still be the limit of the derivative of the top, which is 2, divided by the derivative of the bottom, which is 2x. And when we plug in 3, we get 2 over 6, which is 1/3. Let's do a few of the ones in your homework. The first thing to do is let's do number 6 here. Number 6 would have been impossible with the limit techniques we used to know, but it is possible now with L'Hopital's rule. The first thing to check is, can we use L'Hopital's rule? You can only use L'Hopital's rule if it's 0 over 0 or infinity over infinity. And so, or some other indeterminate form. E to the 0 is 1 minus 0 all over 0, and this is 0 over 0. So we can use L'Hopital's rule, and L'Hopital's rule says we do the derivative of the top. The derivative of the top is e to the x, derivative of e to the x is e to the x, derivative of 1 is 0, and derivative of x is negative 1. So it's minus negative 1 all over 1. This is e to the x plus 1 over 1. And now if we do the limit as x approaches 0, e to the 0 power is 1 plus 1 over 1, which is 2. 2 divided by 1 is 2. So that's the limit with L'Hopital's rule. Sometimes they're much harder. Let's look at number 13. Number 13, we're doing the limit as x goes to infinity, and natural log of infinity is infinity. Infinity cubed is still infinity divided by infinity. This is an indeterminate form. So we can use L'Hopital's rule. The limit as x approaches infinity of the derivative of the top, we have to use the chain rule. It's 3 times natural log of x squared times the derivative of the natural log of x all over the bottom. We can rewrite this as 3 natural log of x squared over x. And if we do the limit as x goes to infinity, again, we get infinity over infinity. So this time we need to do L'Hopital's rule again. So L'Hopital's rule says we do the derivative of the top, which is going to be 6 natural log of x times the derivative of natural log of x all over 1. This is 6 natural log of x over x when we move this down. And so this, again, is infinity over infinity. So we do L'Hopital's rule again, and this time we get 6 times 1 over x. There's no chain rule anymore, so I guess I should say limit as x goes to infinity. Limit as x goes to infinity of 6 times 1 over x over 1, which is 6 over x. And now if I plug in infinity, 6 divided by infinity, that limit is 0. The denominator is getting bigger and bigger and bigger, but the numerator isn't. So this limit is 0. This whole limit is 0. This one can be done by evaluation techniques, by knowing that natural log grows much, much slower than x, and natural log to any power grows slower than x, but you probably don't know that. That's okay. It's more of a BC topic, I think. Let's see, any other tricky ones that we should maybe do? I really like number 7. Let's do number 7. Limit as x approaches 0 here. When we plug in 0, we get 2 times 0 is 0. Sine of 0 is 0. Sine of 0 is 0. And so this we can use L'Hopital's rule. So we're doing limit as x approaches 0 of, this is a chain rule, the derivative of sine of 2x is cosine of 2x times 2. I'm going to put that 2 at the front. Divided by cosine of 3x times 3. I'm going to put that 3 in the front. Now when we plug in 0, 2 times 0 is 0. Cosine of 0 is 1. Sebastian, don't bark. Come here. Divided by 3, and that's our limit. Come here. Sorry, Sebastian is maybe barking. And I'm going to end this video here because that's where we're at.